Hello students, today we are going to start second chapter of class 11, that is relations and functions. Relations and functions. So in today's video, we will be dealing with a very basic thing which comes before relations and functions. In the last chapter, we had studied about sets. We know that meaningful collection of objects is called a set. Now, if we have two non-empty sets, two non-empty set means they have at least one element or maximum there can be any one. Two non-empty sets, right? Let me make two sets, A and B. 1, 2, 3. Now A and B are two non-empty sets. Whenever we start with forming some connectivity between two non-empty sets, the very first thing that comes into the scenario is the Cartesian product. Cartesian product, right? Now, what is Cartesian product of two non-empty sets? If this is a set A, which is a finite set, what I have taken right now, it has three elements. So how do we write it? We had learned it in the last video. Number of elements in A is 3. Cardinal number. Number of elements means cardinal number of A is 3 and cardinal number of B is 4. Right? Now, what is Cartesian product? Cartesian product is represented as A cross B. A cross B. Now, this Cartesian product is nothing but a simple connection between every element of set A with every element of set B, irrespective of any kind of defined relationship they have. We simply have to connect every element of A, like 1, 1, 1, 2, 1, 3, 1, 4, right? Similarly, 2, 1, 2, 2, 2, 3, 2, 4. And then we have 3, 1, 3, 2, 3, 3, 3, 4. Now, here we don't have to consider what kind of relationship or what kind of link the elements of A have with the elements of B. We simply have to connect every element of A to every element of B. That is called the Cartesian product of two non-empty sets. Right? Now, how do we express this Cartesian product? Cartesian product of two non-empty sets is represented by writing the elements of set A at the first place and elements of the set B at the second place. Let me show you. If this is like 1, 1, 1, 2, 1, 3, and 1, 4. See, 1 has been linked to all the four elements of set B. Now, similarly, 2 has been linked to all the four elements. So, we write 2, 1, 2, 2, 2, 3, and 2, 4. The last we have 3, 1, 3, 2, 3, 3, 3, 4. Now the set is closed, right? This was the set which contains these elements. These are called ordered pairs. Ordered pairs. Ordered pairs are, why it is called ordered? Ordered means if we are taking the product, the order of the sets matter. That's why if we are writing A cross B, that means the elements at the first position are the elements from set A, right? And the elements at the second position are from set B. That's why if we are writing A cross B, we have to write elements of A at the first position in these brackets and elements of B at the second position in these brackets. So these are element of A, element of B, element of A, element of B, this way. If we have to write B cross A, so it is nothing but the same ordered pairs in the reverse order. B cross A. So I will be writing just only like this. One is written first, 1, 1, then 2, 1, right? 1, 1, 2, 1, 3, 1, and 4, 1, right? Similarly, we can write all these orders in the reverse order. So this is called ordered Cartesian product, and the output of Cartesian product is written as the set of ordered pairs in the manner on the order which is given in here. If it is A cross B, elements of A at first position, elements of B at second position. And here it's vice versa, right? So these are the ordered pairs. Now see, how many elements are there? In set A, we have 3 elements. In set B, we have 4 elements. So how many ordered pairs have we formed? This is 4 times 3, that is 12. So number of ordered pairs in the Cartesian product is equal to number of elements in A, n of A times n of B, right? So this is the total number of elements in the Cartesian product of 2 non-empty sets, right? Let's do one more example here. If I write 1, 2, A, B, and C. This is my first set P, and this is my second set Q. If I have to write the Cartesian product of Q cross P, now I have put Q at the first place and P at the second place. That means every element of Q has to be connected to every element of P. This way, A1, A2, write A first and then 1, because elements of Q have to be written first. Then A, comma 2. Then start with B, it's B1 and B2. Right? And finally C1, C2. I hope things are clear. Again, you can see cardinal number of P is 2. Number of elements here are 2 and number of elements in Q is 3. So total number of ordered pairs in Q cross P is elements of Q cross P is n of P times n of Q. That is 2 times 3 is 6. Right? So this is the Cartesian product. One more thing that you have to remember is Cartesian product is the maximum compatibility between 2 non-empty sets. There is nothing which can be formed, or a relation or a function or any kind of connection cannot go beyond the Cartesian product. This is a maximum compatibility between any 2 non-empty sets, right? Now, if we do the last example for this, we know we have learned till real numbers. Now, what about Cartesian product of 3 sets? If it is A, B, C, right? This is called Cartesian product. Cartesian word you must have learned in Cartesian plane. What is Cartesian plane? When we write a point by addressing it like 2, 3, this position denotes the x coordinate, this position denotes the y coordinate. So Cartesian plane is a plane which represents a plane like this screen of this laptop or the screen or the pen tablet I'm writing on. So it is a 2-dimensional plane. 2-dimensional plane means when we are considering only 2 dimensions to express any point. So then we have only 2 dimensions, x and y. But when we talk about Cartesian product of three non-empty sets, how do we call it? We write it like A cross B cross C. Now, here we had ordered pairs as the output, right? Ordered pairs. Now, what happens if we take the Cartesian product of three non-empty sets, right? They are called Cartesian triplets. Cartesian triplets, right? So now here we will be getting answers of the form. Now they will not be pairs. One is related to A and then P. One is A, then Q. So this is 1, comma A, comma P. Write all the combinations. 1, comma A, comma Q. Similarly, go for 1, comma B, comma P. 1, comma B, comma Q, right? Similarly, do with 2 for all the components. 2AP, 2AQ, 2BP, 2BQ, right? Now see, what is the cardinal number of A? That is 2. Cardinal number of B, it is also 2. Cardinal number of C is also 2. So how many ordered triplets can we have here? It is 2 times 2 times 2. That is 8. So 1, 2, 3, 4, 5, 6, 7, 8. This is what we get when we have three non-empty sets, right? So how do we, if we have like these, instead of these three finite different sets, if we have R cross R cross R, what kind of ordered triplets do we get? It is like you will be having something here, A, comma, B, comma, C. And these points, basically, that as we had learned, this system is called Cartesian plane, right? Because it is two-dimensional plane. Right now, we are concerned with only length and breadth, or you can say 2 dimensions. When we involve the third dimension into this, it is called Cartesian space, or simply we can call it space, right? A point in a space. A space is a three-dimensional position. Like if I am holding this pen here, this is like space. It has 3 dimensions. According to any point, it has some length, breadth, or some height. So when we have 3 dimensions to a point, that point lies in a space, right? So this was all about Cartesian product